Hello everyone, you are welcome to this presentation. This is part 5 of the engine fundamental course material, and this presentation is focused on a two-stroke engine. The topic to be covered in this presentation are two-stroke engine and comparison of four-stroke and two-stroke engine. The outcomes of this educational material. After the end of this presentation, the student will be able to discuss two-stroke engine, working principle, and compare two-stroke and four-stroke cycle engine. The required material: the two-stroke petrol engine, two-stroke petrol engine trainer, four-stroke petrol and diesel engine trainer. What is a two-stroke engine? A two-stroke engine is an engine which requires only two strokes of the piston to complete all four operations, such as intake, compression, power, and exhaust. The working principle of two-stroke engine. Let's discuss about the working principle in the upward movement. In the upward movement of the piston, both intake and compression process took place. When the piston nears TDC, the compressed air-fuel mixture is ignited, causing an expansion of gas. During this time, the intake and exhaust port are closed. So this is the up stroke, and in the up stroke, in the down port, intake of the combustible substance is taken, and in the upper part of the engine, compression of the fuel mixture is take place, and also when the piston reach a TDC, ignition is commenced. Let's discuss the downward stroke. In the downward stroke, the piston moves from top dead center toward bottom dead center. So during this stroke, two things took place. The first thing is the fresh air enter into the cylinder, and the burner gas leave the cylinder. So expanding gas in the cylinder forces the piston down, rotating the crankshaft. With the piston at PDC, the intake and exhaust ports are both open, allowing exhaust gas to leave the cylinder and air-fuel mixture to enter. Although the two-stroke cycle engine is simple in design and lightweight because it lacks a valve train, it has not been widely used in automobile. It tends to be less fuel efficient and release more pollutants into the atmosphere than four-stroke engine. Oil is often in the exhaust stream because this engine requires constant oil delivery to the cylinder to keep the piston lubricated. Some of these engines require a certain amount of oil to be mixed with the fuel. We can see the two-stroke and the four-stroke cycle engine from this picture. Here compression stroke, and in this case the power stroke. In the compression stroke, the piston moves upward, and the substance or the combustible mixture in the combustion chamber is heat, and finally the spark is given to generate combustion process. So the combustible substance expand and burn, and the high heat generated because of the combustion process develop a thermal energy, and that thermal energy push the piston downward. So the piston move downward with high pressure, and the downward movement of the piston rotate the crankshaft. So in the compression stroke, or when the piston move upwards, air and fuel mixture is drawn into the crankcase, and the rear valve is open, and the spark plug ignited. The power stroke, when the piston is moving from top dead center to bottom dead center, the burning fuel push out, and the rear valve closed. Air plus fuel mixture forced into the cylinder. But in the case of the four-stroke engine, we have four separate strokes: the intake stroke, the compression stroke, the power stroke, and the exhaust stroke. While in the two-stroke engine, we have compression and intake stroke are working together or at the same time in the upward movement of the piston. And the power stroke and the exhaust stroke work together in the down movement of the piston. But here, in the four-stroke, the piston moves downward for the intake, and the intake valve is open, the exhaust valve remains closed. And during compression, both valves remain closed. And during power stroke, the piston moves downward from top dead center to bottom dead center, and the two valves remain closed. And in the exhaust stroke, the piston moves upward from the bottom dead center toward the top dead center, and the exhaust matter leave the chamber through the exhaust valve. Let's compare the four-stroke and two-stroke engine by using different parameters. The first is revolution. The four-stroke engine, to complete the work, it needs 2 crankshaft revolution, and the two-stroke engine require 1 crankshaft revolution, which is about 360 degrees, and half of the four-stroke engine. In terms of torque, the four-stroke engine generates high torque, while the two-stroke engine generates less torque. In terms of inlet and outlet control mechanism, it uses valves for the fuels outlet and inlet, whereas the two-stroke engine uses ports for the fuels outlet and inlet. The other parameter is thermal efficiency. The four-stroke engine is higher thermal efficiency comparing with the two-stroke engine, which has less thermal efficiency. Parameter 5, power to weight ratio. The four-stroke engine power to weight ratio is lesser in terms of power to weight, and a large ratio in terms of power to weight. The sixth parameter, combustion efficiency. It generates less smoke and shows more efficiency. It generates more smoke and shows less efficiency. Lubricating oil. The four-stroke engine requires less lubricating oil, while the two-stroke engine requires more lubricating oil as some of oil burns with the fuel. Parameter 8. Friction. The four-stroke engine. Less wear and tear occur. More wear and tear occur in the two-stroke engine. Parameter 9. Cost and manufacturing. Four-stroke engines are expensive and are tough to manufacture, while the two-stroke engines are cheaper and are simple to manufacture. Weight. The four-stroke engines are basically heavier, and the two-stroke engines are basically lighter and noisier. Thank you for watching this educational material. If you are interested, please share with your colleague. Thank you.